Okay, this is the final installment. This will be part 3 of the study guide. And I want to say two things. First of all, if you want to know how to create your workbook so that you can save it, that's in part 1. And if you want to see how to open it, that's at the beginning of part 2. So now let's just remind ourselves that we've already done all the table methods and other items, the key items and other items. And we need to do data visualization methods. Notice that we have done .group and .pivot and bar H. So let's make sure that we get the ones for the numeric variables. Make sure that we have that. So here we go. And here is .scatter. And notice this option, right? So I can create a scatter plot by just naming two of the numeric, right? So notice that this, right, creates a scatter plot for two numeric variables. So I just can name two numeric variables from the personality data table, and it will produce the scatter plot, but often the scatter plot is hard to read. Um, is there a relationship there, and is it positive or negative? So if we put the line of best fit in there, we can see, oh, there does seem to be a slightly positive correlation there. So we know this often helps us interpret the scatter plot and tell the full story there. So make a note in here under .scatter about this option fit line equals true. And you may want two examples up there. .hist is just so easy. You just say, hey, I want a histogram of the sleep variable. And you can see sleep. This is number of hours that a person got, number of hours of sleep in one day. And okay, so it's a nice histogram. And why did I do this one? And sorry, there is a little bit of an error code. You know, the computer had a slight problem, but notice that if I do this group equals, I can put in a category variable, and then it color codes this chart for me so that I can see which bars, the gold bars refer to males who, and then the females in dark blue, the females were the outliers and who ended up not getting as much sleep as it looks like the males were able to get a little more. So there are some nuanced differences in the sleep patterns between the males and the females here. So remember that this is an option. So remember when you're doing your histogram to not just put in the basic histogram, but make a note in text or give a second example where we do this grouping variable. Box plot is a little harder. This plots is actually from the initialization code. And what do? Well, we specify a column. And why column? Well, the box plot needs an array. So column spits out the array values for sleep, and the label, I don't have to put the label in, but that's helpful. It just shows me what to do. The labels are especially helpful when I do side-by-side box plots. Okay, and then the show means equals true. So you can just run the example that way if you'd like, and it puts in this orange triangle mark where the mean is, but the mean is so close to the median it's not really that illuminating. There are a couple of outliers below, so outliers below pull the mean down below the median. If there are outliers up above, they would pull the median up above. And if there are no outliers, or the outliers are balanced, say two below and two above, then we might see that mean move away from the median. Okay, so box plot, remember the show means equals true is a good option. So make a note about that either in the text that you create or perhaps in the example, whatever you think is best. And I need to make this a, there we go. Need to make it a comment so that it will actually run right. Wait. Oh, it doesn't need a comma. It's not liking that. And I have messed this up good, haven't I? There we go. Sorry. Um, Hopefully you can just skip past that in the video. All right. Then dot plot. Now remember these line plots that we had. And I want to make the point that they're not always that informative. We don't use them. There are some things like the chapter 1 graphs that they showed about the number of times each character was mentioned in those novels. Those line plots were good. And all we do is we just call the two numeric variables that we want to make a line plot of, but this not always informative is there is important, right? It does draw a line plot, but this doesn't tell much of a story. There's just lines going everywhere, and so it's sort of hard to tell what that means. So is it one that we've used? Yes, we've used the dot plot and created line plots. But please remember that the line plots are not always the best thing to use. Um, oh, and I've managed to separate the box plots. So I had another example of the box plots with the show means equals true. Um, Again, I'm just trying to show you so you can see different examples. I would like for you to be pausing the video and creating your own study guide. Don't just do what I do, right? Because we may have different learning styles. You may want to type different text, use different examples, and that will be fine. Um, so remember, we did this in the first video. We created this table perfect that has biological sex, right? It has sit class preference, and then perf, which is the perfectionism scores for these students. Okay, so there's the table, and then we did dot group already. So group counts how many times each level. What do I mean by level of a category variable? Well, biological sex is a category variable with two options in this data set, either female or male, biological sex. And then it just counts how many times the F, that's a level, right, shows up, and the other level is M, and it shows up 55 times. So it just counts how many times each level of a category variable shows up. And then we have this option where I just throw in a comma and then name a function. And then it creates another column with the average for that group. So we can see that the perfectionism scores for the females at about 110 were slightly higher than the males at 106. Is that a significant difference? No. We don't know that. It might be. But this is a really good way to scan the data and see if perhaps there might be an interest in doing a scientific test, an A/B test, to compare the averages between two groups. Bar H is often used with the dot group. And notice that I did the drop. Why? Well, I'm getting rid of this. It tried to do the average for all for both columns, so I dropped the sit class column out of there. So I just have group. And then I was able to create bar H, right? So that's what we're talking about here, creating a bar graph with horizontal bars. And yes, we often use it with dot group and dot sort. So we're actually looking for a table like this, and then we're showing how that category variable looks. Okay, so definitely want to say something about bar H. I don't know exactly how much you're going to use, but again, since it often is used with dot group and dot sort, I thought I'd show that kind of example. And then we talked about this before, but again, if I do pivot with two category variables, right, then I get the first variable I name is biological sex. I have F and M across the top, and then I have back, front, and middle, BFM, so back, front, middle for their preference for where they like to sit in class. And we'd like to do the same thing as the dot group, where we're able to throw in this function and have it give us some values. The problem is with dot pivot, it's not quite so simple. We have to tell it the values we want. So we want values from the perfectionism column, and then I have to tell it what function we want. So values equal and collect equal are important if I'm going to get this, right? If I just have, let me show you, right? If I just do NP average, boom, I get a massive error code, right? But if I do the values right and the collect right, and it's got a small error that it's complaining about, but I do get the perfectionism averages for all of these different groups. And you can see there's a big difference in the back of the class where perfectionistic women, they're about average if you look above, but the males that sit in the back of the class were below average scores on their perfectionism. So you can see all 6 categories and the average for each one. All right, so I'm going to pause the video and we will do functions and special characters in just a moment. So the final things we need to do from our study guide are go over the arrays and functions. Okay, so let's, and again, I hope if you want these, you can pause the video and copy some of these down. So NPA range creates an array of ordered values. So NPA range 5 creates the array 0, 1, 2, 3, 4. If I include 3 inputs, the first thing is where it starts, right? It starts at 0. It goes up to 10. Well, actually, it stops 1 less than the stopping number. It starts at the starting number, but it stops one place in the sequence before the ending number. And then the 2 tells it to count by 2s, right? If I put 5 in here, it would count by 5s, and it stops really quick. So let me go back to 2. And there you see we have 0, 2, 4, 6, 8. I can make an array just by specifying the values. So there I specified the values 1 and 3 and 5, and it makes the array 1, 3, 5. And remember that we can do math with arrays, and it will do it to everything in the array. So I created this array called T. That is just the numbers 1, 2, 3, 4, and 5. And then 5 times T, oh, it just multiplied all of them. So the first 5 multiples of 5, 5, 10, 15, 20, and 25. So remember that this works with addition, this works with multiplication, whatever you want. We can do 5 plus T, and it will work. So I'm going to go back to this way. So whatever you need to say to yourself, again, if you need some extra text, make sure to put in there that you can do, you can add, we can multiply by 5. Put in the text that makes sense to you, and some examples if you need it. NP pi, it just pulls in the value of pi to what, 15 decimal places or however much decimal places it stores. The same thing with NPE. NPE is a real number near 2.7. Okay. And what does NP average do? Well, I'm creating an array. Why? Because NP average works on an array, and it calculates the average of every value in the array. So I created this array X, 4, 9, 7, 11, and 15. And you can see that when we do NP average, it calculates the average. And the same thing works with these other functions, right? The sum of X, it adds up all the elements in that array X. The minimum value from X was 4, and the maximum value from X was 15. So they work the same way. You don't have to put an NP in front of sum and max and min. The computer knows these functions, sum and max and min. It doesn't happen to know average. We could ask why. What in the world? How does the computer not know how to average? But that's an NP, which stands for NumPy. All right. And so now these special functions, we only use these once or twice so far in the course, but we can do these trig functions. We just put the NP dot in front of them. The problem is that the input angle measure is in radians, not degrees. Okay, so that's why you see this NP dot pi over 4. Well, I'm putting in the value pi over 4. Okay, and it's calculating the sine of that. Oh, and I was going to do cosine. And right, you can see it calculating the value. So there we go. Now I've shown you something in the study guide for all of these. So even if you're having trouble thinking of the example you'd like to use, you can use the examples that I've shown here in the video. So remember that you're allowed to put more on your study guide than what I put. You don't have to use as many examples as I did. Make the study guide for you. It's going to be your study guide when you are doing the midterm. So please personalize it and put in what you need and take out what you don't, and make sure that it's going to be a really good assistant to you as you're taking your test. Good luck.